we'll look at more examples on how to translate informal language into formal language here. So let's do something a little unusual, fun. Okay. So let's say suppose U is all students in this class. U represents that set, and T represents all the tests to be given in this class. And let's define these predicates. P of U comma T be the students U cheated on test T. And let's try to translate the following using quantifiers, oftentimes involve multiple. All right, take a look at the first one. There is a student, okay, who cheated on or will cheat on every test. That means you actually can find a student who cheated on every test. So you can find. That means there exists, right? There exists. Okay, there exists a student because we let you represent students. So U from this capital U, such that every test, that's where the for all test, right? For all T in T, and you cheated on T. So that's what it is. Now let's look at the second one. Every test was cheated by someone. So any test, every test was cheated by someone. Okay. So in other words, like just pick any test for all T in T. You can always find some students and the student cheated on that test, right? So that means you can always find a student. There exists a U in U such that like U cheated on T. That means P of U T. So actually, I forgot to use the predicate on here. I should just use P of UT. So this is the second one. Now let's look at the next one. Every student cheated on some test. So every is any just pick any students, right? For all student U from U, and you can always find a test that the student that you pick cheated on that test. So therefore we are going to say there exists a T in T. So that's where the there exists comes in, such that P of UT. Now let's look at the last one. There was at least one test that everyone cheated on. So this test is probably most difficult one. Everyone cheated on that particular test, right? So that means there exists such a test, T, such that now you just pick any student from the class. So for all U in U, P of UT, the U cheated on T. So that's how we translate all these into formal language. All right, so that's the first example. Now we are gonna actually close this section by talking about how to negate these, okay? How to negate these. So first of all, we want to do a little quick review on the simple statement that involves only one of the quantifier here. So like here, the negation of for all x in D, Q of x is there exists, right? X in D, such that we have to negate the predicates. And similarly, the negation of an existential will be a universal statement. So this will be for all x in D. not q of x. So the rule is quite simple. That's the rule. Now let's extend this a little bit further. So the reason we review that because we are going to apply it to here, okay? So now the negation of for all x, there exists y such that p of x. Let's do it step by step. This, again, if you remember the way that we translate statement with multiple quantifiers is in the order we see it, right? So here this is actually, first of all, it is a universal statement for all. And then, so we are going to look at this structure like that, right? Okay. So which is like this structure. For all x, q of x is this guy. So applying this result, I should have the negation should be an existential statement. So there exists x. And then such that we have to negate. What do we negate? Negate this whole thing, right? So I'm going to do it multiple steps. So I'm going to just write down. I will be negating this guy. So negating the exist y such that p of x, y. So that's what we are trying to negate. Now, to negate this guy, that's why we review this. So the negation of an existential statement is a universal statement. So therefore, now this is equivalent to, let me copy down the first part, there exists x such that, okay, now the negation is for all y, right? For all y, and then comma, not, you have to negate the second part. Okay, so this is how we negate this whole statement that involve two quantifiers. Similarly, to negate the second one, so there exists, and think of this as your, so there exists x, think of this as your q of x, okay, q of x, like this is my predicate. Now, it will be universal statement, and then you will have to negate the second part, right? Again, I want to do it in two steps. Now, that means for all x, the negation of this for all universal statement will be existential statement. So there exists y such that not p of xy. All right, so this is the rule to negate these two types of statements. Now let's go back. To this example that we just went through, and try to negate all these statements. Okay, by first negating the symbolic form and then translates the negation in English. This is always a good strategy and a good practice because in this way you can negate it without, the chance of making mistake is very tiny, okay? Now let's look at the first one. So let's negate this guy. So the negate this guy is gonna be for all. By the way, you can always, I would suggest you maybe always maybe write down this result. This is the negation of the corresponding statement here, and then apply that to this example. So let's first begin with the first one. Negation of the exist will be for all, right? For all you in you. Okay, comma, and now you're gonna negate this, continue. So continue to negate this. The negation of for all will be the exist t in t such that you are gonna negate this one. All right, so this is really just simply applying the rule. It's pretty simple in my opinion. And now let's try to translate this back into English. So here's the translation. So we begin to say, hey, for all students, you, right? For all students, I'm going to just say for all students. There is a test such that, well, we have to negate this one. This actually, if you remember, P of UT means student U cheated on test T. So if not P of UT, that means student U did not cheat on the test T, right? So in other words, for all students, comma, there is a test such that students did not cheat on that test, right? Student did not cheat on that test. Okay. All right. The second one is